In this application, we are going to find how many quarts of 6% butterfat milk and 1% butterfat milk should be mixed to yield 50 quarts of 5% butterfat milk. So what we notice right away is we have some numbers here, some with percentages. So these three numbers are all percent, but notice this number of 50 tells us number of quarts. So this is a clue as to what the two different categories should be when we set up a table of information. One of those will be number of quarts, and the other will deal with percent of the mix. So let's set up our table. We have a 6% butterfat mixing with a 1% butterfat. So I'm just going to write 6% and 1%. Our last column typically is some kind of a total. Notice that it does not reveal how many quarts of either of these percents of butterfat milk are being mixed. It simply says that we're having a yield of 50 quarts. That is the total. So I'll just use X and Y, making a total of 50 quarts. So when I'm mixing, that means I'm adding to make a total of 50. The first variable I've written to go along with 6%. 6% as a decimal is 0.06 multiplied by the number of quarts. That will be mixed or added to 1%. Be careful, it's 0.01 multiplied by the number of quarts. Since we don't know it, we're using Y. That will equal the total quarts. Now, this total is made up of two different things. One part is the quarts, which is 50. The other is the percentage that we are trying to create, and that's 5%. So we must multiply 50 quarts by the 5%, or 0.05. From this, we get our system of equations. X plus Y equals 50, and 0.06x plus 0.01y equals the product of 50 times 0.05, which is 2.5. Now, it looks like substitution would be a quick method, so I'm going to rewrite that first equation in terms of y. So that means I'm subtracting x from each side of that equation. Negative x plus 50 will be on the right. So I now have a substitution. Instead of y, I'm going to substitute negative x plus 50 into that second equation. With that substitution, 0.06x plus 0.01 times the new value of y, that's our negative x plus 50, equals 2.5. Remember, 2.5 came from multiplying 50 quarts times the 5% mixture. Now you'll notice we only have one variable in the equation, so we should be able to solve for x. We'll be distributing the 0.01 to each term in the quantity. We start with 0.06x, and then we'll have subtraction of 0.01x, and when we multiply 0.01 times 50, and when we multiply 0.01 times 50, that will give us positive 0.5. All that now equals 2.5. Notice we have some like terms to collect on the left, and we'll be subtracting 0.5 from each side of the equation to collect our like terms. 0.06x minus 0.01x leaves us 0.05x, and 2.5 minus 0.5 gives us 2. Notice that 0.05 is connected to x with multiplication, so we'll have to divide both sides of the equation by 0.05. That leaves x equals 2 divided by 0.05, which is 40. Now going back to the table, we can figure out what x represents. X is the number of quarts at the 6% solution. So it's 40 quarts at 6%. We still need to find the value of y. So we'll go back to our first equation. X plus y equals a total of 50 quarts. X is worth 40 quarts. So x will be replaced, or substitute 40 for x, plus y equals 50. Subtracting 40 from each side of this equation, y equals 10 quarts, and y is at the 1% solution. So you might see how useful it is to have that table to remind you of what each variable is representing. X represents the 6% solution, which happens to be the 6% butterfat milk, and y represents the 1% butterfat milk. So if we mix 40 quarts at 6% with 10 quarts of the 1% butterfat, that will yield our 50 quarts of 5% butterfat milk. In this application, a store sells cashews for $4 per pound and peanuts for $1.50 per pound. The manager decides to mix 10 pounds of peanuts with some cashews and sell the mixture for $2 per pound. How many pounds of cashews, which we'll let equal C, should be mixed with the peanuts so that the mixture will produce the same revenue as with selling the nuts separately? So when we scan, we notice some of the numbers have dollar signs, and some of the numbers here don't have dollar signs, but they're followed by the word pounds. So we have two categories of numbers. We've got pounds, and we have dollar value. What we're mixing are cashews and peanuts, and the mixtures have different dollar values. The cashews sell for $4, and the peanuts sell for $1.50. So I'm going to mix cashews and peanuts to get a total. So when we look back into the problem, it says the store sells cashews for $4 per pound and peanuts for $1.50 per pound. The manager decides to mix 10 pounds of peanuts. So we actually know how many pounds of peanuts are needed this time. So instead of P, I'm going to use 10, because we actually know 10 pounds will be used. What we don't know is the total number of pounds. So that's where I need to use a variable for this particular application problem. Now I can take into account the dollar values. Cashews sell for $4. So 4 multiplied by the number of pounds of cashews will be added to 1.5 multiplied by 10 pounds of cashews, and that will be equal to our total value. Now it says that we're trying to sell at $2 per pound. So $2 multiplied by the total number of pounds. Since we don't know the total number of pounds, I have to keep my variable t to represent total pounds. My two equations now for the system come from C plus 10 pounds equals T for total pounds. C plus 10 equals T. The next equation is 4C plus 1.5 times 10 equals 2 times T. Now it would be helpful to know how much 1.5 times 10 is equal to, and when you multiply those you get 15. So if you wanted to write that as 4C plus 15 equals 2T, that might be more helpful. Now we can see from the first equation it's already written in terms of T. So we can take C plus 10 and substitute that for T in the second equation. Now we have 4C plus 15 equals 2 times this new value of T. C plus 10 is that new value. If I distribute 2 to each term in this quantity, I'll know what each individual term is. On the left, 4C plus 15 now equals 2C, and 2 times 10 means plus 20. This time I've got a variable on each side of the equation and a constant term on each side. So I have to make sure that I'm going to collect all variables on one side. I'll subtract 2C from each side so that I can eliminate it from one side and collect it on the other. I now have 4 minus 2, which is 2C plus 15 equals 20. If I subtract 15 from each side, I'll be able to collect those constant terms. I now have 2C equals 5. When I divide by 2, I can solve for C. 5 divided by 2 is 2.5, or 2.5. So that 2.5, representing the variable C, that tells us that's the cashews at $4 per pound. So 2.5 pounds of cashews are needed. Now we also need to figure out what the total number of pounds are. So I'll go back to that first equation. C plus 10 equals T. We know that C is 2.5 pounds added to 10 pounds to make the total number of pounds. It looks like 12.5 is the total number of pounds in that mixture. So we solve for both of our variables now.